industry. The request came from the market because at that time a lot of steel structures were and still are protected through hot dip galvanizing. We all know hot dip galvanizing as a very cost efficient and also durable corrosion protection. But as we all know, you need to bring your steel parts to the hot dip plant for dipping in that liquid hot zinc to have, let's say, the zinc protection on the steel. So you need to bring your structures to the factory and then you can erect them on site. Most of the people are very happy with that type of protection, but as it is a depleting layer, so the zinc will deplete in time. So the protection comes at a certain moment in time at the end. And when there is no zinc anymore or no galvanizing protection, your steel structure will start to rust. So the market and the industry and the clients were requesting, how can I re-galvanize my steel structure on site without dismantling it? And we developed a liquid applied zinc, which is giving a similar protection as galvanizing. The advantage is that our Zinga can be applied in the workshop or on site and gives in such way a lot of benefits in terms of application and in rehabilitating the steel structure. So this is where Zinga started. And of course, it took us a couple of years to fine-tune the formulation and to have the certificates and the approvals to bring it on the market, where we prove that effectively it is giving an active cathodic protection to the steel. So this is in short the history. Apart from Zinga, we also developed, next slide, Rick. Apart from Zinga, we also developed a range of complementary coatings. As you can see in this picture, first of all, you can see that the Zinga is packed in normal cans, just like a paint, in different sizes, depending on the type of application you want to do. So it looks like, a normal paint, but it is not a paint, as it is a liquid, pure zinc. Our business model is based on a distributorship, which means that we have one local manufacturing site, which is based in Belgium, where we do the formulation, the production and the export. And at this moment, we have more than, in more than 110 countries in the world, a local distributor. So, for example, on the African continent, we have at this moment 15 distributors in 15 countries. And for East Africa, with the hub in Kenya, there we have already a long-lasting relationship with Epic Steel, who is our distributor for more than 12 years now, and a very successful distributor with many, many different applications in different industries. As you can see, we have the products which can be applied by brush, roller, and spray. Rick will tell more on that. But we also have the ones in spray cans. And the spray cans are very useful for small retouching and small, repairs. Next. This is just a map where we see that all the countries colored in dark blue is where we are active through distributorship. And a distributor holds a local stock of the products, is also, trained to give the right services and eventually also, application services. Next. In this list, you can see that also Kenya is marked. And the good thing of having such a large network is that having a local presence is very important to comply with the local content and also to give the pre-sale support, the support during application, and also post-sale support. So this is very important. We just do not sell a product, but we sell a solution. Yeah, and this is what we are aiming for, and also the same from our distributors. Thank you. Okay, now I will hand over to Rick, who will go through his part of the presentation. Thank you.
And then it comes back automatically muted. See, it's okay. Now it's not muted. Ah, okay. It's staying open now. Okay. Okay, we're going to go over the characteristics and advantages, and you will hopefully see that the main difference between the Zinga product and paints. Okay, you have the main principle. Okay, you have active cathodic galvanic protection. So the active part is the zinc. Is depleting to protect the metal which it's being covered with. Okay, so the protection is galvanic. The Zinga does generate a voltage, and the voltage is flowing through the steel 24 hours a day. And because that voltage is flowing, it's physically impossible for you to have corrosion cells setting up anywhere on the steel. It's physically impossible, so you cannot have corrosion. And that's in the atmosphere, it's underwater, and we even have some jobs in the sea. And that the zinc just depletes every month, slowly from the top, always from the top. So the metal is never compromised in any way. Secondly, you have a passive barrier. So you have the active zinc that wants to dissolve to protect the steel. But because it forms a barrier, this barrier is actually a layer of zinc salts, okay, zinc oxides, and within a few weeks it forms zinc carbonates, and the zinc carbonates make the zinc coating very tough, very tough. We challenge people to hit it with a hammer and try and crack it or try and knock it off, and they can't do it. As hard as they can hit that zinc, it will not crack. That's how tough it is. So the passive barrier protection is very important. And the nice thing is it's automatic. You don't have to do anything. You just leave the zinc outside in the weather, and it forms the barrier coating. And apart from the toughness of the coating, the formation of carbonates on and inside the zinc film, it increases your adhesion. So normally after 7 days of outside weathering, in the rain and the wind, if you do a pull-off test with a hydraulic puller, you're getting about 6.3 megapascal. But see, after 3-4 months, it goes up to 9 megapascal, and after 12 months, it goes up to around about 11.2 megapascal. That's extremely high, because if you look at thermal zinc, that's only 5 megapascal, 5 or 6, and Zinga is sitting at 11. So the adhesion strengths are phenomenal. So these are some of the hidden, more abstract points of Zinga. We say it's not a paint, so it does not form a closed film. Okay, paints will form a closed film. So once they've dried, there's always a fine layer of the binder above the pigmentation, and that's what gives you your gloss, whether it's a high gloss or a dull gloss. Zinga does not have that. Okay, it's a sealed film, not closed. So it seals itself with the zinc salts that form. And this also keeps it very flexible. Its flexibility is 17% compared to paints which are about 3-4%. This is a diagram to let you see. On the top, you can see the Zinga layer and the iron layer. And then underneath, you have paint over the iron, just to show you the two different scenarios. Now, if you look Here, if you have impact damage, you can see the Zinga, the electrons, those little circles with the E, that's your current flowing from the Zinga into the steel to protect it. So that current is flowing around the clock, 24 hours a day. When you look below and look at the paint impact, it impacts right through to the steel, it damages the paint. And the paint is just a passive barrier. It's dead. It's just sitting there doing nothing. All it's doing is keeping oxygen away from the metal surface. That's all it's doing. Now look what happens here. The Zinga, the current is still flowing through wet weather, dry weather, winds, rain, hurricanes. But look at the paint. It's now rusting underneath the paint. Okay, because the paint is not giving any protection apart from that layer to stop the moisture and the oxygen. So that's the main difference there. One's active and one's passive. This is also to show you how the differences in Zinga. I'm back on again. You can see the zinc particles in zinc paint are very large. So there aren't as many inside the zinc film. The zinc made that we use for Zinga is made specially for Zinga, and it's very, very, very fine particle sizes. It's microscopic sizes, and because of this, you get more particles per volume. So in 1 cubic centimeter, you're probably going to have at least 3 or 4 times more zinc in Zinga as you would in paint. And why this is important, how is it going? Okay, here you can see the zinc paint. You have a little bit of current flowing between some of the particles, but because there is a break between each of the particles and between the particles and the steel,
we seem to have lost connection.
Yeah, we're just going to try and get Rick back. Let's see, looks like it's coming back now.
okay.
Start again your presentation.
They can see the diagram with the zinc-rich paint?
No, there is no diagram at the moment.
You launch your presentation again.
What, from beginning?
I think you might need to reshare the presentation.
Can they see that? Okay. Yeah, here we have the advantages. Okay, you can use Zinga by brush, roller, painting gloves, which are used for doing steel cables. And you can apply, even non-professionals can apply it. We often give, sorry?
Don't see your screen presentation.
I don't understand that. It's
The presentation is not visible.
why is it doing this?
Yeah, okay.
Okay.
Go on now.
Okay, so we can train people on site in the various countries, and where you have a professional applicator already within your country or within your region of the country, well then they learn to use Zinga very easily. It's like spraying a car, you know. It's one component, and you add the solvent to the dilution. For airless spray, like you see in the photograph on the oil tank, you just thin it down 5% with airless, or 10 to 15% with a normal spray gun, conventional, and you can spray it on. It's as simple as that. There's no mixing with other chemicals, no induction times like epoxies. There's none of that. You just add the solvent and you apply it. You can apply it in a very wide range of weather temperatures. So if it's -20 up to 45 degrees, you can apply Zinga. If it's 95% humidity, you can apply Zinga. You cannot apply paints anywhere in the world above 70% relative humidity. If you do that, it'll fail. You'll have blushing and blooming and things like epoxies, because they absorb moisture from the atmosphere, and you get blooming, which is big white blotches all over the paint, and all sorts of problems like that. And it will delaminate on many coatings like PUs and so on. So with Zinga, up to 95% humidity, you have no problem at all. You have no limitations. So where most projects stop, when the inspector on site says that 70% humidity, you've got to stop spraying now. With Zinga, you don't have to do that. In fact, we proved this in Akosombo, a big project we did in Ghana. Every morning, because of the mist, the relative humidity was always up in the 90s, first thing in the morning. And with paints, they couldn't apply anything before 10:30, 11 o'clock at the earliest. But with Zinga, they could go in there and start working 8, 9 o'clock as normal. So time-wise and cost-wise, it makes a big difference. Again, you can use Zinga as a brand new system, and you can use it for repairing, hot dip galvanizing, paint systems, and zinc thermal spray. So you have a wide range of uses for this coating. Right. It's got a quick drying time. It's touch dry in 10 minutes. You can walk on it after 15 minutes. So when you're doing tank tops and so on, and you have to walk across the tank to get to the other side, you can walk across the dried zinc. It won't mark, and it will not be affected by dragging hoses and things across it for your blasting hoses. With the epoxies, you can only blast one section of a tank roof, and you have to leave it until the next day, so you can walk on it, because epoxy dries so slow that your blasting grit would stick to it. And if you walked across it to get to the other side of the tank, you're going to mess it up with your boots. So Zinga will never peel. It's not brittle. It's very, very flexible. You can compress it. So if you have very heavy weights going over Zinga, it'll never crack or split. It'll compress quite easily. With local damages, you can do touch-ups with Zinga. So if you've done a large surface area and you have a damage through maybe handling with a crane or the back of a truck, if it's been scratched quite deeply, it is very, very seldom you scratch through to the bare metal. But if it was a very heavy damage to a small area, you can touch it up with a brush or a roller. Okay, so whether you apply it with airless or whatever beforehand, the damage can always be touched up with a roller or a brush, and it will blend in with the rest of the Zinga. So you won't see any touch-up marks after a few days. When you're welding a Zinganized steelwork, your burn back is 2 to 3 millimeter, which means that each side of the weld, you're going to lose up to 3 millimeters in width of zinc. With paint, it burns off up to about at least 70, 80 millimeters will burn off both sides of the weld. Then you have to recoat all that. With Zinga, it burns off 3 millimeters each side of the weld, which is pretty incredible. And there's no undercreep. Okay, it's physically impossible for Zinga to have undercreep corrosion, because with paint you will have. And you know, if you have osmotic blistering, when paint gets damaged or porous with age, water can go through the coating to underneath. It starts corroding under the paint, and then you have film undercreep or corrosion undercreep. With Zinga, that's physically impossible because of the voltage flowing through the Zinga from the Zinga into the steel, which flows into every square millimeter of surface area. So it's impossible for you to have undercreep. Here's a good example of the compression of Zinga. They're doing these wind turbine towers. These towers weigh 150 tons, and you can see that they're spinning it to rotate it when they're coating. And that shiny piece you can see in the top photograph, that's actually the Zinga being burnished. It hasn't come off. The surface of the zinc's been burnished away, the oxide layer, and underneath is a pure zinc, and that is what you're seeing. If you can do an experiment for yourself. If you spray a small panel with Zinga, leave it half an hour or so, and then get some Scotch Brite or some steel wool. And if you rub it, not hard, you can knock off the grey oxide layer, and underneath you'll see bright, shiny zinc. So that is quite clearly showing you there that the oxide layer is peeling on the surface. And again, this is what's stopping any weathering, any rain-carrying salts and so on. They can't get to the zinc because that light grey oxide layer is passivating the zinc. So what the shiny bit you see is the active part, and the matte grey is the passive part. You can reload Zinga at any point in its life. So you can reload Zinga after 1 hour, you can reload it after 20 years, and it will always melt into the original layer. So whether you have 2 layers, 4 layers, 6 layers, if you X-ray it like this, all you'll see is 1 layer of zinc. Zinc paints will striate into layers. So if you apply 3 layers, you will have 3 layers in an X-ray. And this is why the conductivity is so poor with zinc paints. But with the Zinga, because it always forms 1 solid layer, it remains very, very highly conductive. I'll see if this comes up.
50 minutes to go.
Oh, cracky. Okay. So you can see the zinc particles here. That layer on top is actually a layer of gold dust on the surface to show you the top of the first layer. They've applied a second layer, and you can see it's mixed into 1 single layer because the gold dust is mixed right through the 2 layers. And on the end there, that is zinc paint. Okay, you can see the gold layer in the middle. So there's 2 layers there split by the gold dust to show you there's 2 separate layers with no conductivity and no voltage protection. Okay, we have all these granule sizes, but we're running out of time. I don't want to waste too much time on this. And again, we have 96% of atomized zinc, so the entire layer is full of zinc. There's no gaps in between like you get with zinc paints. Here is a test we do to show people. We have architects and engineers who cannot believe that Zinga can produce such a high voltage. On the left, you'll see a zinc paint panel, and they're measuring it with a voltmeter using a silver chloride half cell, and you're getting 759 millivolts. When you look at the Zinga test panel, it's 1,124 millivolts. That's how much voltage is flowing from the Zinga into the steel. And for those of you who've done any work on boats or buried pipelines, the voltage from Zinga is higher than the voltage from aluminium anodes. It's the only coating in the world that can do this. Here's an immersion test, okay, to show you 1 form of zinc versus Zinga. The panels are sprayed, the zinc's allowed to get hard, and then they cut it through with a very sharp blade. They cut it through into the surface of the steel, and then they expose it to salt spray, salt fog mist. So the salt spraying onto it 24 hours a day. You can see the zinc spray is immediately, it's rusted inside the cuts. The zinc is still perfect because the voltage is throwing into the steel, fully protecting it. You can overcoat Zinga for aesthetic purposes, or for color coding of pipelines and tanks. A lot of major companies do a lot of color coding with different colors, and you can apply it in a duplex, which would be Zinga plus a polyurethane. If it's a very, very severe atmosphere, like inside oil refineries with acidic fumes, you can put it on as a triplex. So you can put on Zinga, then an epoxy MIO coating, and then the finishing coat. So here you can have Zinga by itself as a standalone system for a C5, which is a coastal system. So at the coast, it'll give you 25 years protection. You can use it at 20 to 40 microns as a shot primer. So if you're working on a large structure that has to be recut and re-welded in places, To stop it from corroding during these processes, if you're taking a few weeks or months to do the work, you put on a very, very thin layer of Zinga and you'll have no corrosion anywhere. This allows you to drill the steel, cut it, re-weld it, whatever. And then you just touch up the welds afterwards and that's it, it's finished. Zinga does not generate and spread toxic fumes. Okay, we have certification for this. And also for the spread of flames in a fire. Zinga will not spread flames or initiate a fire. And again, we have BS 476, part 6 and 7, which we can give to anybody who requests these. Apex Steel may already have copies of these on file. So we are fully certified against all these things. Again, the shelf life of Zinga is unlimited. We've taken tins that are 12 to 15 years old and we've stirred it. We've diluted it and sprayed it and it's worked perfect, absolutely perfect. So the shelf life is indefinite. The pot life is indefinite. And Zinga will not react to ultraviolet like paints. So it cannot degrade with age and break down with UV exposure. It can only break down as it depletes to protect the steel underneath. It'll never ever be weathered away. Okay, here's a quick system to show you a comparison. Two layers of Zinga can be applied in one day. Well, in fact, it can be applied in 2 hours. And if you compare that to metallization, which is thermal zinc being sprayed on, you spray it on, it has to be sealed with a tie coat. It has to, or it'll be contaminated. Then it's top coated with a polyurethane. That's a minimum of a 3-day system because the epoxy takes 24 hours to cure. With hot dip galvanizing, again, it's minimum 4 days because each layer of epoxy has to cure overnight before you can apply the next coating. And then the zinc epoxy with polyurethanes, again, is multi-layer system. And again, it's a minimum 3 days. So now in many countries, the contractors are renting scaffolding, which is extremely expensive. They're renting compressors. They're renting cranes to lift structures into place. So if you do a Zinga project and you finish the whole job in 1 day or half a day, you can compare these costs to having these things on site for 3 days or 4 days, bearing in mind that this is for good weather. If you have bad weather, on say day 2 or day 3, it's postponed. So suddenly your rental is going to maybe 6, 7, 8 days in bad weather. So those costs alone, it's really, it can escalate. It can add on another 30–40% to your costs of the project quite easily. So with Zinga, you don't have the additional rental costs. You don't worry about freezing cold weather. In some countries up in Northern Europe, they can't spray paints for half the year. So with Zinga, if you're doing tower maintenance for pylons, electricity pylons, you can do your maintenance every day of the year if it's not raining or snowing, because you're not worrying about temperatures. So that and mixed with the rental costs of your equipment, it's a massive saving in costs. So this is a quick snapshot of what we discussed. It's one component, so there's no mixing of chemicals, big time savers. You can have 25 years with a warranty if one is wanted by your client. We have all the laboratory tests done by third-party laboratories in Europe. So we do our own testing on many systems, but we always have it tested by outside recognized laboratories, so that anybody in the world can contact them and they say, yep, all the paperwork that we gave to Zinga Metal that you have is all genuine. We did the testing. The shelf life, unlimited. The pot life's unlimited. You can use it as a standalone system all by itself, or you can use it in a duplex or triplex system. It doesn't contain any toxins. It doesn't contain carcinogenic solvents, which you find in most epoxies, you know, your MEKs and all those sort of chemicals, MIBK, they're all carcinogenics. You can use Zinga underwater. You can use it inside potable water tanks for drinking water, which we've done around the world. We've done it on ships and so on. Zinga will take any impact from hammers, from vehicles and so on. It will never crack or flake, never. It can work down to -40. So if you're doing cryogenic tanks that hold liquid nitrogen and so on, you can coat the tanks with Zinga, and it'll withstand the massive contraction and expansion of the steelwork on these tanks, and it'll never ever crack. Again, you can apply it in very, very heavy conditions, up to 95% humidity, and you can replace, or you can repair, or build up the thickness of hot dip galvanizing and zinc thermal spray. So you've got a wide range of uses for Zinga. And again, we have all the surface preparations and so on, but we won't go into that. You can read these at your leisure. Surface preparation, first line maintenance. I'll just cover it very quickly. We have in Malaysia server oil platforms. They completely forbid the use of any power tools or blasting on these platforms, because if any sparks are generated, it can cause an explosion. So all this treatment, they did it mainly with wire brushes. And believe it or not, we had pull-off values of higher than a blasted steel pull-off value. The testing was done by ExxonMobil laboratories in Malaysia, in the head office laboratories, and they were getting pull-off values of 12 megapascal, which is unheard of. So, and that's using a wire brush to prepare the surface. So again, you won't get 25 years. You may only get 5 years because of the rough preparation. But if you want to hold an area while you're doing other work around it, that area will not corrode for 5 years. So the frontline maintenance has proved exceptionally well received. These are some examples you can see onshore. Hot pipes, cold pipes, and so on. You can see the before and after photographs. And the thing is, because they're galvanized, they won't have any problems with the salt landing on it afterwards, like you do with paint. You have no osmotic blisters and other paint issues. These are the companies involved, and you can see these are all major players around the world, very big players. And these are the ones who are using our first line maintenance. I think for the tests and approvals, I think I'll hand you over to Christian. I think you may want to see these for yourself when we give you copies of this PowerPoint, because there's a great many of these.
You can just go through it quickly, Rick, if you want.
Quickly, have I got
then I go with the references.
Okay.
Just go through it, yeah.
Okay. Okay, we'll go through these quite quickly here. Okay, these are the quality control things that we have in place in Belgium. So for every single batch manufactured, Zinga Metal keeps a 2 kilogram tin on the shelf with the batch number and the date of manufacture and so on. So if anybody had a complaint, we can pull one of the samples from that batch and we can examine it ourselves. Or if necessary, we can bring in an outside examiner or an outside third-party inspector, and he can take it off the shelf himself and he can perform the tests. So we're very, very transparent in everything we do. Here is the various systems that we do. And these are the thicknesses. So at 90 microns, which can be applied in a single coat with an airless gun. You can do one single coat with that, and you already have a C4 high system on the steel, or a C5 medium. So that is C5 medium. So that's up to 15 years protection. Then at 120 microns, you got a C5 very high. Okay, and that's a 25-year protection from Zinga. And again, you can apply that in 2 coats, 1 hour apart. So it's very, very fast. We're also certified to the new ISO CX systems, which are for offshore platforms. And we also have the IM4, which is offshore immersion. So that's around oil platforms, because when you're out at sea, the ocean currents have different levels of salt, different temperatures, different levels of oxygen, and so on. So IM4 is a bit different to the IM3, which is immersion inside harbors, marinas, and so on. So is the difference. So we cover every single eventuality, both above the water and under the water. We also have certification for NORSOC, which is also one of the industry standards used all over Europe and in other countries. Again, you can see it's 4,200 hours immersion in seawater and 4,200 hours in cyclic testing. And the pull-off value is 7 megapascal. So it's not an easy test to pass. A lot of paints fail these tests. In fact, they fail them halfway through. Sintef, they also have done, this is a big laboratory in Norway. They also work with the offshore industry, and they've also done a great deal of testing of Zinga over the years. We have microbial-induced corrosion. Okay, we have, there's been a lot of bacterial attacks over the last few years, which have escalated actually. The first microbial attack was actually traced back to near China in 1921. And since then, these microbes, they're called sulfate-reducing bacteria, they've expanded around Australia. Then they were found in Europe, they were found in Italy, then France, then the UK, then Germany, and so on. And these microbes, the bacteria, they can eat through 2 millimeters of steel per year. So they're very highly aggressive, and they show up more in dirty water. So if you have a busy harbor where ships are leaking oil, or the exhausts are putting oil and stuff into the water, it's very oily and greasy. It sticks to the metal, forms a biofilm, and these things thrive on biofilms. So we've had extensive testing done on Zinga as well. In fact, the Zinga repels the microbes. Here we have some calculations on pin piles, which are piles buried below the seabed. They support monopoles, which have the wind turbines mounted on top. So we've had a lot of testing by Ramboll, who's one of the biggest consultants in Europe. Here we have SGS, which is one of the biggest fire testing companies in Europe. They've done all the fire testing, smoke generation, toxicity generation, and so on. So we have all the certification for these. So if people are welding zinc-enhanced components, they're not putting themselves at risk. You won't get risks of cancer. You won't get zinc fever like you get from welding galvanizing, hot dip galvanizing. You'll have none of those problems when welding Zinga. Potable water. Again, we've been doing this for many, many years. So we normally put 120 microns of Zinga inside water tanks. And we found that on steel tanks on board ships and big yachts, 120 microns, after 12 years, it's lost roughly 8 microns. So it's down to like 112 microns. So it's virtually not even 10% loss. And these tanks contain chlorine to combat bacteria in the water from these tanks. So even with chlorinated water, you're still only losing between 7 and 10 microns over 10 years. So it's actually the same as, or if not better than hot dip galvanizing for the water tanks. Friction coefficient, again, this is a very critical factor all over the world, and now including China and other Eastern countries who now comply with the worldwide building codes. And when you're bolting together any large structures like bridges, multi-story buildings, all the steel framework, the bolts have to have a slip coefficient of minimum 0.5. Zinga is 0.52, so we comply with that. Hot dip galvanizing is 0.31, so it does not comply with it. So when guys have massive galvanized beams, like they had in one big project in China, they had to blast clean thousands and thousands of holes, or the beams around the holes. So when they bolted together, they would comply with the 0.5. So every single hole had to be blast clean and coated with Zinga on top of the galv. So with Zinga, with none of those problems, you blast clean and apply the Zinga, and automatically complies with international building codes. The US Army and the Navy, NATO and the Ministry of Defense in Britain, they all use Zinga. They use it on tanks, they've used it on ships, submarines and so on. So we have a good background in military. Here's some of the major companies like Land Rover. Zinga was used on production runs of Range Rovers. So that just shows you the strength. When they put it onto a 85,000 euro car, you know it has to be good. Then you got all the oil companies again, and electricity companies. They all use Zinga now. They've all accredited it onto their list of approved products. Again, we have the frontline maintenance we discussed with the wire brushing and so on. Again, here's more before and after photographs. Here's that one there. Yeah, they're just showing you again before and after. And again, this is all done to wire brushing. And you can see the finished result. And again, you can see that a lot of these jobs where you have corrosion that's localized, it's very easy to wire brush and then use a paintbrush, 100mm paintbrush, and you can brush in a small area of corrosion and forget about it. If the guys want to overcoat it with paint to blend in with existing parts, they can do so as well with the polyurethane. So again, small touch-up projects are very simple. Here's some more examples of frontline maintenance showing you that corroded pipe is water under pressure. And again, here's more. So again, all small local touch-ups, you're actually galvanizing these ones, so it's very, very fast and efficient. This is just showing you that the wire brushing used, sometimes that they may use a angle grinder with a wire cut brush. Okay, but so it's degreasing, wire brushing, and then on with the Zinga. Again, a lot of people use Zinga sprays because there's no spillage. The guys have special holsters on their belts. So when they're climbing up ropes, up and down ladders, it's easier to use a spray than it is to carry a bucket of Zinga and a brush. So working at heights, yeah, they have special belts that they carry 2 or 3 aerosol sprays. So it's been adapted. So there you go, wire brush, paintbrush, and then whatever you need. So low areas will always be brushed by hand. High areas where climbing is involved will always involve aerosols. And I don't know if you can take over the. Okay, you just show it next.
Thank you, Rick, for this very detailed explanation of what is Zinga and how we differ from a traditional paint. So just to summarize shortly, we all understood that Zinga is not a paint because of its very high percentage of zinc in the dry layer, and this is the reason that it behaves differently. It behaves actively similar to what metallization and hot dip galvanizing is doing, but we have the advantages that we can just apply it just as simple as a normal paint. So in terms of surface preparation, in terms of application, we do not differ from the traditional paint coatings, but we do have a lot of technical characteristics which is giving you an economic benefit. And bottom line for all of us who are in charge for maintenance or who are in charge to select a suitable corrosion protection for a steel structure, we all have to consider the cost per square meter per year of protection. And this is the only comparison you can do. Yeah, so you cannot compare just a product with another product, and just comparing what is the price of 1 liter versus the cost of another liter. So this is the wrong calculation and the wrong comparison. The only way to compare is cost per square meter, of steel to protect against the number of years of protection. And as we have seen, Zinga can be applied with different thicknesses, giving you different number of years of protection, and as in such a way also giving you the flexibility, in terms of maintenance costs. Just to go through a couple of references, because where is Zinga applied? Because this is speaks more to the reality. Yes, Rick, I'll have to ask my assistant Rick to go through the slides. So the references of Zinga, we are present in many different markets, as you can see, from the energy sector to agriculture to railway, name it. Wherever you have steel will corrode and you need to protect it. So now we will go through a couple of pictures. So where you will see where Zinga and eventual top coats have been used. So in offshore, it's a challenge, of course, because you're offshore, you have the wind, you have the sun, you have the sea breeze, you have a lot of external elements who can contaminate your steel structure. So it's a very, how would I say, serious corrosive environment. So you have to do it well. Good surface preparation, checking the salt level on the steel, and then this platform has been painted with Zinga as a primer. But of course, we aim for a plus 25 years protection. So, and the client has also some special specifications in terms of coloring, because you have a lot of pipes and tubes. For security identification reasons, they must be colored. And as we learned through the presentation, you can use Zinga as a standalone system, which means only Zinga, which has a gray finishing. But on top of Zinga, you can apply an epoxy or a polyurethane, depending on the specification. So this is just to showcase you that on such a platform, where you have color specifications, it is a Zinga-based system where on Zinga we apply an epoxy sealer, or we top coat with a PU polyurethane in any color. Next. You can see how steel can corrode. So this was the situation of a lot of parts of the structure before. Next, after surface preparation, blasting. You have your nice clean steel where you start applying the different coats, from Zinga, intermediate coat, and then you finalize with the PU top coat in red, yellow, or other color. Next. You can go next and next. Another one. Next. I just go through these because these are all related to the offshore. So this is bridges. Bridges is another market segment industry which is very demanding in terms of long-term, efficient corrosion protection, and also, of course, a solution where the downtime is very limited. Because, if you have to block a road or you have to block a railway for doing maintenance, the faster you can reopen the structure and make it available for public, the better, of course. So this is one of the longest steel railway bridges on the southern hemisphere in Australia, the Verbrugghe Bridge, 800-meter long. So Zinga has been used for repair and maintenance, and gradually, of course, the structure needs to have a full rehabilitation. So this was a hot-dipped, so previously hot-dipped galvanized steel bridge, where Zinga was used for, let's say, the day-to-day maintenance, for doing touch-ups and stop the corrosion where the galvanizing was damaged. And then finally, so the railway company decided to do the full bridge in Zinga. Next. So this is a bridge in Norway, which has been Zinganized in 1985. And just to showcase the tracking record, we are now 2021, which is almost, let's say, 37 years further. In that whole lifespan of the bridge, I believe they only consumed 1 can of 5 kilograms of Zinga to do the retouching and the repairs, which were accidentally damages by bicycles hitting the bridge and other things. So just a nice example of a steel bridge coated with Zinga with a plus 35 years lifetime. The easiness, of course, is after the lifetime, you only have to wash the structure, high pressure washing. You don't have to blast anymore, and you can put new Zinga layer on the old one, and they will melt together to reactivate the original cathodic protection. And it gives you, or it gives the steel structure another life just by simple Zinganization. Next. And of course, this is all related to cost efficiency. I mean, Zinga is only a technology, it's a tool which gives you the opportunity to protect your steel structure in a cost-efficient way. These are other bridges. It just gives you, how would I say, an image on where and what structures Zinga can be applied. Next. The previous pictures of bridges were all renovation, rehabilitation, but as we said, Zinga can also be used on new steel structures, and this is the world's fourth longest suspension bridge. So this is a bridge which has been finished, I believe, 2 years ago in Turkey, in the Bay of Izmit. Next. So this was a bridge with a specification. This is, can you go one back, Rick? One back. Okay, no. Apparently, there's only one picture of the Izmit bridge, but you just leave it on the Izmit bridge, yeah? So this bridge is a new bridge, and it is made of different modules. So the bridge is built on site. So there is a workshop next to the river. And in that workshop, they fabricate the modules, the steel modules, they blast it, they paint it, and then the bridge is built step by step. So that was a life expectancy of 25 years. So there was a Zinga-based coating system with an epoxy sealer and a white polyurethane top coat. So we have won that project against Jotun, International Paint and others, major ones. And the reason why the client has chosen a Zinga system is purely because of throughput. Throughput means how fast you can prepare, paint the modules, because this is, the faster you can prepare it, the more cost saving, because the workshop, which is on site, was costing $1 million a month. Through using Zinga, they could close down the workshop 3 months earlier in the project. So 3 months earlier means there was a saving of $3 million just by choosing the right, let's say, coating. So it was drying time and overcoatable time that made that Zinga was selected for that project. So it was purely 2 technical characteristics, which were converted in a financial economical benefit, and this is the exercise we all have to make, cost efficiency. Remember what I mentioned at the beginning, any project, and we're talking about corrosion protection, it all comes down to cost per square meter per year of protection. And then we have been proven that we are very competitive. Next. Other structures, this is Verbrugghe, but this is a video, if I remember well. Okay, but good. Bridges, just to, yeah, we continue with the bridges, Rick. Just to let you know that also we have good, how would I say, good sales and consumption of our coating even in China, where there is a tough competition, of course, but even though we succeed to convince the project owners to use the Zinga technology on super large steel structures, as you can see, which is one of the Shugong Bridge in Beijing is one of the, how would I say, latest structures which have been installed. 45,000 ton of steel, which is enormous. Yeah, as you can see, where we consume 300 ton of Zinga. It was also related to, how would I say, cost effectiveness. And remember that we are not limited to size of structures, yeah, which you are with hot dip galvanizing. Next. Next, Rick, if Rick is there. Okay, wind turbines is there. Just to refer to some, let's say, other offshore applications. Yeah, so these are the part of the wind turbines which will be in the, how would I say, in the soil, yeah, under the metal, and that's also a Zinga unique system. Next. Yeah, this is just in the workshop where you see surface prep and application of the Zinga. Yes. You see that these are colored yellow because yellow color is in Europe offshore the norm, yeah, where you have the part which is just above the sea. Yeah, you need to color them in yellow just for security, visibility. Yeah, when it's misty, so yellow is the color. So there again, you have Zinga plus a top coat. Yeah, all depending on the specifications and the expectations of the client. Yes. Yeah. Next. Here you see in practice. Okay. Yes. Next. Yeah, it gives you an impression of the size of such steel structures. Yeah, so you can imagine that this is a very intensive preparation and application. So the faster, the better. Yeah, so that the operational costs, yeah, will be reduced at the end. Next. Yeah, these are more, let's say, traditional applications in industry. So the top left picture is a cement bagging plant. Yeah, so it's which you can recognize: silos, structural steel, piping, and so on. This was a project done for Dangote in Ghana, where the complete infrastructure was coated with Zinga. So this is coastal, which means coastal, 300 meters from the seaside, always windy, UV light, and the salty environment. So 2 layers of 60 micron will protect 25 years. Of course, the bottom picture is giving you Zinga application, but top coated with a wide polyurethane, depending on client's expectations. Next. These are storage tanks. We have succeeded also to protect some storage tanks in Mombasa for Hashi Energy. and also gas tanks. Yeah, but Lance or Charles can tell you more or share with you all the references of Zinga applications in Kenya for the last 12 years, yeah, because we do have many of them. But storage tanks, yes, mainly the outside of storage tanks where we have a very cost-effective solution. And again, depending on the expectations of the client, if he wants to have a very shiny aluminium finish, we can put our nice pure aluminium coat on top of Zinga. Or if you want to have a white finishing, we just will apply a white PU on top of Zinga. So all these systems are possible, but always keep in mind that the primer, the first layer, will be Zinga, who is offering you that continuous active cathodic protection to the steel. Yeah, and this is an advantage. Yes. Next, next, because this is just application. Next, yeah, next. This is more in marine environment where you see some jetties, pier legs, conveyor structures. So also suitable to be treated with Zinga. Next. Yeah, this is towers. Towers, light masts or light poles. So this is a quite huge light mast, as you can see on the little on the picture on the left hand side. You see the little man next to it. He's almost as big as the nut and the bolt. But it gives you an idea of how big these light masts are. So after doing a successful demonstration for the Port Authority of Singapore, they decided that we could treat all the 30 light masts at the Port of Singapore. Next. So you see also that if gray is acceptable as finish color, because this is Zinga, the gray matte, if this is acceptable and there are no color requirements from the client, so then you have a very performant system, yeah, with Zinga unique, because it's very easy for retouching and very easy afterwards just to put a new layer on the old layer and to extend the lifetime of your asset. Power plants, yes, in China, the largest coal power plant in the world, 8 gigawatt, has been constructed, and for the reasons that we already mentioned, hot dip galvanizing was not an option. There were beams also with a length of 124 meters long. There was no option to galvanize them, so client decided, because there were other issues too, quality issues, compatibility issues also between different hot dip plants. So they decided to use Zinga in the workshop and on the local workshop, so on the spot. And this was again the best solution in terms of timing, but also in terms of costing and efficiency and logistics also. Yeah. Next. Saudi Arabia, this is a water intake next to desalination plant. There again, this was maintenance of these pipes and pumps. Next. I mean, price comparison is not, how would I say, it is important, of course, because as I mentioned, people intend to compare in the wrong way. If we say, okay, how much does it cost? Okay, our team and our distributor will be able to share with you what the cost is of, let's say, 1 kilogram of Zinga. But it is a wrong comparison to compare it with another type of paint, which might be cheaper or not. The only comparison is, of course, the square meter comparison, because if you say 1 kilogram of Zinga has a certain cost, how much square meter can you protect with 1 kilogram of Zinga? What is the thickness, the layer thickness? Because we know that the layer thickness, the zinc layer, is directly, how would I say, related to the lifetime and the number of years of protection. So if you have 2 layers, of course, it will give you a double lifetime, but compared to 1 layer, which is giving you half of the lifetime, but it's also cheaper. So be careful in your comparisons, and our team will help you and assist you to do the real, let's say, cost comparison. Yeah. Next. Because in projects also, you may not forget that if you look at a project for rehabilitation, a bridge, a silo, a pipe, a pump, or whatever, steel structure, if you want to rehabilitate such a structure, there's a lot involved. Yeah, so it is mobilization of materials, of workers. You need to have fresh water, you need to have compressor eventually. So you have a lot of equipment, tools. You have the labor force, yeah, to do the cleaning, to do the application, to do the inspection, to do the whatever. Yeah, you have the scaffolding eventually. So, and the coating costs. The coating cost is generally speaking between 3 and 5% of the project costs. So be aware that by choosing the right coating, for example, a Zinga with some very, how would I say, interesting technical features, like drying time, overcoatable time, so the total process time, this in your 3 to 5% can have a serious impact on all the other costs in your project costs. So if, for example, scaffolding is 40%, by using Zinga, you can drop your 40% scaff cost maybe to 20%. So my experience is traveling a bit everywhere in the world, that we should pay attention and learn to make the right calculations, yeah, and cost comparisons, yeah, because we do forget sometimes to how would I say, to check on the losses, for example, or to check what could be impact of the right coating on the other elements within your project cost. So this is an exercise everybody should try to do, and Lance and his team understand this very well, and they are there also to help you out, yeah, to make the right comparison, so that you can also make the right decision, yeah, in favor of course, client, yeah, who is looking, of course, for the right solution, yeah, within the right budget. So from my end, I have to thank you all for your attention. I presume that you have a lot of questions, but we are here to answer a couple of questions, yeah. Otherwise, you're free to share your questions, and we will make sure that all your questions receive the right answer, yeah, through our distributor or ourselves. So if someone has a question, you just tell us. Rick apparently, yeah, he's on the phone with me because apparently he cannot hear us, but I can forward the questions to him, yeah, if there is any. So thank you for that. Charles? Nobody has questions?
Thank you, Christian. Thank you, Rick. So we have quite a few guys in this webinar. If you want to have a question answered, please ask your questions. We have a few minutes.
There is a question on the.
Okay, so yes, I see Mr. Pius. Thank you for the question.
Mr. Pius says, does one have to remove old Zinga to apply a new layer in case of retouch? Rick, you're on mute. If you want to reply, did you catch the question?
You said he's asking if he has to remove all the Zinga.
If you have to remove the old Zinga before you apply new Zinga.
No, when you're doing touch up on old Zinga, you just clean off the surface to remove any atmospheric salts that have been deposited, any bird droppings and all that. Just normally you can use steel wool or a Scotch-Brite pad and just wipe it down with that, and then you apply more Zinga. It's as simple as that.
Is that answering the question? No. So this is one of the duties of Zinga. Once you have applied Zinga on a new structure or on old model, you have the number of years of protection of Zinga.
Christian,
And
you're muted.
prior to applying a layer of Zinga, you only have to wash and clean, let's say, the Zinga layer. You have to remove some contamination, but then you can just put a new Zinga layer on the old one, and they will blend together to one single layer again. Offering the cathodic protection. Are there any other questions coming in? Yes, there's one. What if you have a color paint over Zinga primer? What?
Hi, Christian, can you hear me?
Apply Zinga after expiry period.
You're muted at the moment.
Well, if it's got paint on top, then the Zinga should still be okay unless the paint's broken down.
Okay.
Then it'll be a reblast. Recoat with Zinga.
Christian, if you could just press unmute.
Just repeat, suppose you have a treatment system. You have the Zinga as a primer, and the top coat is failing. Do you have to remove the
Hi, Christian.
Zinga or only the top coat?
If the blast is very good and you just remove the top coat, that's all that's required. Just re-expose the original Zinga and then put more Zinga back and then put the top coat back, because the metal won't be corroded or pitted.
A question, this is Jafet. Any compatible paints product that one can paint over Zinga in Kenya? Any quick measure?
Could you repeat that question, please?
Yeah, I was saying any specific product that in Kenya is compatible with Zinga that now you can paint over Zinga. Any specific examples of such paints?
We've run successful tests. We have sent data sheets to Zinga and have got approvals for typical top coats like Plascril, which is an acrylic polyurethane. My understanding, Crown has similar products. So these are twin pack acrylic polyurethanes. They work very well. We've had the go ahead from Zinga. We've shared with them the technical data sheets. So yes, there are top coats that are available in Kenya. And you just let us know exactly what your application would be, and we would be happy to assist with the correct data sheets and application methods and so on and so forth. Is that okay, Joseph? Or?
Okay, yeah, I think that's okay. Thank you. I don't know.
Yes, I'm still here.
Okay, maybe as my last question from my side, any specific application of Zinga in Kenya in potable water? That's a treatment in use as potable. Any specific examples on the use of Zinga in Kenya in the potable side sector?
Yes, Joseph, we've done. There have been a number of water tanks that have been Zinganized. We'll be happy to share those references with you. They were blasted, then Zinganized. We're going back 2 years now, so and those tanks are still in very, very good condition. And those were specifically for the panel tanks that you see around a lot, the steel panel tanks. We've done water bowsers for Kenya Defence Force. We did 30 water bowsers for the Defence Force, so they moved away from epoxy-coated water tanks, and we completed 30 water tanks for Kenya Defence Force.
You know what the damn problem was, Christian?
That was done in conjunction with the Defence Force and with Isuzu East Africa. I met one of you 2 weeks ago who said the Zinga was holding up very, very nicely. Unfortunately, we couldn't get to see them because those trucks have been deployed to the border. But I'm trying to get hold of some photographs or some feedback from Isuzu on the same that we could share with you. Is that okay, Joseph?
Yeah, I think that's okay. Thank you.
Any other questions? And again, we will send out feedback form where you can also include your questions or any comments.
Okay, that's good, Charles.
Okay, I see one person raising their hand. Please go ahead, unmute, and just ask your question.
Hello, thank you for the presentation. I would like to know, other than marine environments, has Zinga been tested on other corrosive environments other than marine environments?
Who's answering that one?
I'll leave that to you, Rick. On the testing side.
Can you answer that, Lance, about the electrical pylons?
I think the question is more concerning has the test been carried out? So, for instance, has it been carried out perhaps in chemical plants? If I'm reading your question correctly, Engineer Henry, is that correct?
Yes, yes. I wanted to know whether it has been tested in other corrosive environments.
Yeah, we've used it in oil refineries, which are very corrosive because of the sulfur smoke. And we've used it in abattoirs where they hang up the meat. So, oh, crikey. We've used it in gold mines in Africa. So we've coated railway tracks in the UK and Singapore and France with Zinga. So the actual railways themselves have been coated. We've used it on truck chassis, big trailer chassis, where they're operating along the coastal routes and the trailers get rusted very quick. So yeah, we've used it on vehicles. We've used it on big storage sheds where they store fertilizer, because fertilizers can eat holes through the metal walls of these big sheds. So we're using Zinga on those as well. So yeah, I'm just trying to think non-marine. I mean, all the road bridges, rail bridges. We've done big buildings. In the heart of London, we coated a very famous building. We did all the floor beams on the famous Gherkin building. We've done a lot of repairs on buildings in different cities. On the structural steelwork of these big buildings.
Just complement to what Rick says, that apart from marine, if you say other corrosive environments, yeah, of course, marine is perceived to be one of the most, how would I say, aggressive and corrosive environments, but on shore, yeah, where you have humidity, where you have, of course, oxygen, humidity, which are the two elements for corrosion. But then you have accelerators, like we call them, salty environment or chemical impact or mechanical impact. So Zinga is not the magical product which can solve all the corrosion problems, of course. So you need to understand the characteristics of Zinga and also its limitations. Apart from offering that very good active cathodic protection, there are some environments that Zinga cannot withstand due to the nature of the zinc. So if you have a direct contact with chemical products, for example, where the pH value is quite low or quite high, so acidic or alkaline, then of course we must understand the situation and then make an assessment if a Zinga standalone system is the ideal situation, or if you need to top coat the Zinga with a paint which is suitable for that specific environment. The same for temperature resistance. So Zinga works well, yeah, optimal, up to 120 degrees Celsius. But if you know that your steel parts, yeah, having higher temperature, then you must be aware of it, and that Zinga will not perform ideally. But to overcome the temperature limitation of Zinga, we developed a second Zinga, which is called Aqua Zinga. It's a water-based zinc silicate offering cathodic protection to the steel, similar like Zinga, but that one is resisting to 600 degrees Celsius. Yeah. So the limitations of Zinga can always be converted, let's say, or compensated, yeah, by a suitable, let's say, top coat or alternative. So the message is, we need to understand very well the structure, where it is, how it is, what are the environmental conditions, is there a direct impact of something, only atmospheric, immersion, buried, yeah, and also apart from that, we need also to understand what is the expectation of the client, yeah. How many years of protection do you want or do you prefer? And in function of these two, yeah, we will always make a kind of a proposal, yeah, with option B. And you can go for the maximum optimal protection, which will probably be more costly, or you go for, let's say, a suitable short midterm solution. So it all depends. So, and all this makes a solution, let's say, cost effective or not. Yeah. So we have questionnaires put in place, yeah, to help our distributors and the client, yeah, to describe the how would I say, the project, yeah, the environmental conditions, and all these questions and all these answers will help us also to draft and to prepare a suitable, let's say, specification. Yeah.
Thank you.
Okay.
Engineer, you happy with that? Does that answer your question?
Yes, it does.
Thank you.
I have another question.
Yes, sir.
Considering that we are, the world is moving into a more sustainable goals, I would like to know whether Zinga can reduces the carbon maybe footprint on many of our projects. Does it assist us to reduce the how much probably we the waste, that carbon footprint?
Considering your application times are reduced considerably, so we're talking, application times going down from 72 hours to 2 hours. Immediately there's a huge impact on application times. It's less crane hire, so on and so forth. I can't comment on the manufacturing procedures or so on and so forth, but we've immediately got to understand this is a single pack product. We're not using multiple chemical additives in the forms of isocyanate hardeners and so on and so forth. So immediately it's better for the environment. As I say, I can't speak for on the manufacturing side. Obviously, I will allow Zinga to comment on that side. But certainly from an application point of view, it's a much more efficient way of coating structures than it would be using a multi-layer system with multiple types of coatings. Bearing in mind, if you need a 3-layer system, we're using an epoxy primer as a rust inhibitor, then we're using an intermediate coat, which is sometimes an epoxy polyamide epoxy, and then we have to put a polyurethane top coat over that to give a protection lifespan of, let's say, 10 to 15 years. Whereas with Zinga application, immediately be cutting the application times down and be giving 20, 25-year lifespan, which means we don't have to revisit that structure in the next 20 to 25 years, obviously with a maintenance being applied to the structure. And then to recoat that structure at the end of the day, we're not having to blast everything off. Then which is what you would have to do with a normal passive coating system, we can then just go high pressure wash the structure and reapply another layer of Zinga, extending the life of that structure for another 20, 25 years lifespan. We completed, I think to date now, we've completed 40 pylon rehabilitations for Kenya Power. And without that, we would have, just wouldn't have been make economical sense. We would have to bring those pylons down. Some of them were showing some structural signs of collapse, which was why Kenya Power was worried about these structures. But we were able to go and rehabilitate these structures, and now we don't have to worry about those structures for another 15, 20 years. So I think the benefits as far as going in a more economical, more efficient way, definitely. I think we can show multiple examples of that.
Thank you for that.
Thank you.
All right, I think there's no more questions for now. So we'd like to wrap this webinar up. And I'd just like to say a big thank you to everyone who was able to attend, and took time out of their day to listen to us. We hope this is just the beginning of an ongoing conversation and more trainings in the future, more webinars in the future. We really appreciate Mr. Christian and Mr. Rick for taking us through. And we really learned a lot today. So again, we will be in touch with each and every one of you guys, see what else we can answer, how else we can assist you guys. And we can learn more about the projects you guys may be working on and how Zinga can come into play for those projects. So thank you, really appreciate. We'll be in touch soon. You guys have a wonderful day and a wonderful evening ahead.
Thank you.
Thanks, Charles.
Thank you. Bye.
Thanks, everybody. Bye-bye.
See you, Lance.
Thanks, Rick. Thank you. Thank you, Christian. Thank you, ladies and gentlemen. Thank you for your time.